In this video, we shall be continuing our discussion on object-oriented programming with an introduction to classes. Now you may be thinking, why are we having a video providing an introduction to classes when I have seen classes so many times? Well, that's a good question. First of all, as I've said, every single thing inside of C# is an object. And where do objects come from? They come from classes, which means for the most part, all of your code is going to reside in some class. Well, with that being the case, we simply could not show you any applications to create without throwing that keyword class out there. So with that being the case, we got in there, we started getting our hands dirty by creating stuff, but we never gave you the formal official introduction to classes because, well, it really didn't fit within the scope of the lecture when getting you up to speed with the basics of the C# language. Now, back in Volume 1, we did provide an object-oriented primer, and we gave you a very quick overview of what a class was and how to instantiate a class into an object, but that was just a very quick intro to get you up to speed for the creation of Canon 2 and also Canon 3. Now, it is time for us to go ahead and slow things down and take a true look at classes. So the objective of this video is to provide a basic overview of what classes are. And for doing that, there's 5 key elements that you need to understand by the end of this video. So let's go ahead and just pull out the whiteboard. So there's 5 key elements. All right, what are these key elements? Number 1, what is a class? Now, at this point, we should all have a solid understanding of what a class is, but I'm going to take it just a little bit further this time. Next is going to be basic class syntax. You have to understand the syntax. If you don't, how are you going to create a class? Next thing is going to be what goes into a class. So what kind of things can you put in there? Obviously, we're creating code, and, well, almost all code resides within classes, but we can break that down and be a bit more specific about what type of code is going into the classes, and we'll do that here. All right, so number 4, modifiers. You've heard us mention modifiers before, and you've seen us use them, things like public and private. Well, with classes, at the root level, there's 2 modifiers that we're going to be using, and we're going to discuss both of them. As a matter of fact, Logan, we're going to get C# involved, or Visual Studio involved, and we're going to see if we can give them some quick examples. And then finally, how do you create an object? Creating objects. In other words, how do you instantiate a class? So these are the 5 key things that I would like for you to walk away from this video understanding. So let's go ahead and start with what is a class. Well, simple enough. We've said it a million times, it feels like. A class is nothing more than a template or a blueprint that you will use to create or derive an object from. Okay, now what is an object? Well, it is an encapsulated thing containing data and functionality that can somewhat exist by itself, if you will. And that's very cool because it gives us this ability to program in an object-oriented nature. Now, of course, I am simplifying this like crazy right now. Please keep that in mind. But that's what a class is. It's nothing more than a template. Well, when we picture a template or blueprint, we don't actually picture something that exists in memory. It's something that, well, we can derive from to build something in a variable and put that in memory. But as I've hinted at, if we think all the way back to when we talked about value types and reference types, the class does indeed get loaded into the heap. Okay, so it's almost like it is an object. So as a real quick example, let's go ahead and come over here and draw out our heap. And if anyone has any trouble remembering what this stuff means, go back and watch the value types and reference types video, because I think I did a pretty good job of making it as clear as possible. So let's say we've got numerous classes that we're going to be using. When our application executes, the CLR is going to load these classes into the heap. So here we go. a class. So we'll call this class A, and we'll call this class B. So they actually exist on the heap. And this becomes really important in understanding because we're going to be discussing static members really soon. We're going to have static methods. We're going to have static fields. Where do these static items go? Well, the idea of them being static means that you're not going to be able to instantiate them, which means you're not going to be able to have multiple copies of. And we'll make that very clear when we get into those specific lessons. But because we need a place for these static members to go, well, it makes perfect sense for them to reside inside. So I'm just going to put little dots to indicate like static fields or something. So here they are residing inside of these classes that we've loaded onto the heap. Another thing is the fact that when we create a class, we also define its behavior or its functionality. And in doing that, that means we go in there and we create a whole bunch of methods. Well, we wouldn't want the methods to basically be copied into every instantiation of that particular class. That really wouldn't be efficient, would it, Logan?
Right, because a method is always going to have the same functionality between different instances. That's by nature of an instance. They have to do the exact same thing, so it would be unnecessary to actually duplicate the code between the instances. Instead, store the code once inside of the class.
That's right. So you can't be wasting memory if you were populating your memory with the same code over and over and over.
Right.
So we can come down here, and what I'm going to do is expand this a little bit. So we have a method lookup table. So now all of our methods are existing inside here, and the same thing is going to happen down here. So there's all of our methods in class B. Now, of course, with this class, which is still a blueprint for an object, we can instantiate an object. So here is an object. And these objects, they point back to the type object that has been loaded on the heap. So down here, let's go ahead and instantiate class B. So there it is. And it's going to point back over here to its object type. Okay, so that is a very important concept to understand. When somebody says, what is a class? And you quickly come in there and you say, well, it's basically a blueprint or a template that you can use to derive objects from. This is true, but do make sure you start picturing at this point that it is something that gets loaded onto the heap. Now, we're going to come back to the whole static members thing a little bit later on, but at this point I want you to understand that it's not just that blueprint laying there, but it is actually something that exists when the application is running. All right, from there, let's go ahead and move down to syntax. Let's check these off as we cruise along. So this guy, what is a class? Out of the way. Syntax. The basic syntax is very easy. I'm going to leave out attributes, Logan. Just letting Logan know that, or anyone else that is familiar with a more sophisticated look at the C# programming language. So simple syntax. We have modifiers. Next, now this is required. You'll notice the square brackets indicating that it's optional. Next, the keyword class. Next is going to be the identifier, the name that we're going to give this class. Next is going to be our base list. This is when we start, and you'll notice it's optional. This is when we start dealing with inheritance, which is not going to be covered in this video. But for simple syntax, this really does need to be included. Then, of course, we're going to have our class body. And then we're going to close off our curly braces. And then optionally, from those of you coming from other languages where it's required, we can put a terminator in there. Okay? Now, that is the basic syntax for defining a class. So keep in mind, optional, optional, and finally, optional. What is not optional is this and this. Okay, so that's the basic syntax. You've seen it half a dozen times. Okay, you've seen it numerous times, way more than half a dozen. All right, next, what goes into a class? Now, this is really important because, well, you're going to be coding within classes all day long when you're writing your applications. Well, that's a very simple answer. Members go into a class. So members. What kinds of members are there? Well, there's quite a few. To name off the 3 most important types, let me just do it right here. We've got fields. These are just your local variable within the class scope, if you will. We've got methods. This is the behavior that we assign to a class. And then finally, we've got properties. Properties, kind of like a method, but kind of a cross between methods and fields, if you want to look at it that way, where we can go in there and we can use assessors to directly get information out of fields or put information into fields, or we can simply define our own functionality as if this was just a regular type method. So there's all sorts of interesting things we can use.
Right, and the actual things that a property can do can vary greatly. It can be simply a way to access a field, or it can be something that would return a calculation indifferent to fields. It's really up to you. It's kind of like, I would call it something like a structured accessor function.
There you go, and I like the sound of that. Okay, but is that the only kind of members that we can have inside a class? No, there's plenty of others. We can have things like, and I'll just jot down a couple of them. We can have constants. We can have constructors. We can have events. Ooh, here's a big one. We can have other types. Yes, indeed, we can have other types. We can have a class nested inside a class. Back in the enumerations video, we talked about the ability to define an enumeration inside a class. These are defining our own types within a class. I mean, in the end, what is a class? I mean, yes, it's a blueprint and all, but it is a type that we are defining ourselves. Hey, like that for a really high level, what is a class? It's a type, our type. Now, we can have our own types nested within our root level type, if you want. In other words, we can have our own classes nested within a class. And, well, you just use the basic syntax right there, but you place it down within the class itself. Now, in doing that, our modifiers are going to change just a little bit, and we'll discuss all of that in the next few videos. But I just wanted to point out, before leaving away from members, that types is indeed one of the things that can exist inside of a class. And a class is a type, which means a class can exist inside a class, nested classes. Okay, so that's an example of some of the things that you will find inside of classes. Members, field members, member methods, properties, etc. Okay, so that gives us a good understanding of what goes into a class. All right, next is modifiers. What are modifiers? Well, modifiers actually break up into 2 different key areas when talking about the class. We've got our accessibility, if you will, and then we have what I like to call other modifiers, the abstract, the sealed, and the static. So let's go ahead and start out with access modifiers. So let's see, I'm trying to make as much of this fit as I can. So let's see, something about right there. So I can just bring this on over. Bear with me, guys. There we go. Okay, so access modifiers. You've seen them. You've used them. Public, private. I think that's probably all I've used at this point, Logan. But we've got protected and internal protected. We've got all sorts of cool things we can use with a class. Now, right now, we're dealing with classes at the root level, if you will, within the namespace, not nested, okay? That's the key thing here. We've got 2 access modifiers that we can use. The default one is internal. Okay? And then we have public. So, Logan, go ahead and bring up Visual Studio real quick.
Okay.
And just create a new console app real fast.
Alrighty, actually let me switch to this one and grab a new console application.
Okay, so here he is, new console application. That's all you have to do. Very, very, very quick. Look at this. So we've got class program. And you'll see it's following our basic syntax. All of the optional stuff has been omitted there, and in our opening and our closing curly braces. Now, when we don't see a modifier here, the default modifier type is internal. What does internal mean? Let's go ahead and jump back over here real quick. Internal means that basically we can only see this class inside of the assembly in which it's defined. The assembly? Well, now you got to think all the way back to Volume 1 in the .NET lessons. We talked about when you create a project and you compile that project, basically you are making an assembly. So the internal means the class can only be seen by other classes inside of this assembly. If we were to create another assembly, that other assembly could not utilize the particular class marked internal. And that's really an important concept to grasp. Let's come down here and draw a little picture. So this right here is our assembly. And inside the assembly, let's say I've got two different classes. I could have one class that's been marked as public and one that's internal. Now, if I was to create another assembly, and this other assembly, of course, everything resides in classes, so it's got some classes in there. This class, or this class, as long as it referenced this assembly, these classes could see this guy because he's been marked as public. Public means that anyone who's referencing this assembly can see the class. This guy, on the other hand, right here, he's been marked as internal. He can only be used by classes inside of this assembly. He cannot be used over here. Answer, no. Right, Logan?
That's right. Internal means only internal to that specific assembly, which means in the end that executable or DLL file will, if it has classes marked as internal, they have to basically stay within inside of that file. If you mark something as public, then that means it's possible to reference that assembly and bring in any classes or access any classes you want from that other assembly.
Exactly. Okay, so with that, we all have a basic understanding. So coming back over here real quick, which one was it? This console. Ah, there we go. We've got two Visual C Sharps open, and we're going to use both of these in just a second to demonstrate this. But I wanted you to see, right now, internal is not being used. That's the default. If you don't use anything in front of class, ding, it's an internal class, okay? So keep that in mind. As a matter of fact, you're going to see this in just a minute when Logan starts giving you an example. He's going to show you what it's marked as. But I could type out the keyword internal right there, and it's going to take it just fine. It'll be the exact same thing. I just want to make that clear. Okay, so jumping back over here. So public, that means other assemblies that reference the assembly that the public class has been defined in can see it and utilize it. Internal, they cannot. It just keeps it protected within that assembly for use by other classes that reside in that assembly only. Boy, that might sound confusing. If so, back up and play it slowly. Okay, so with that, now what we want to do is give you a very quick demonstration. Why would you want to have one or the other? Well, first of all, internal would be if you just happen to be creating your own classes that you simply don't want anyone else using for whatever reason. Just mark them all as internal, or, well, don't mark them as anything. By default, they are internal. And that way you're creating an application that, well, everything is protected, if you will. No one else could say, ha-ha, I'm going to take Logan's application, and he's got some very nice classes in it, and since they've been marked as public, I'll use them in my application. Well, if everything's internal, you can't do that. But here, let's go ahead and give an example, kind of like a real-world one, where let's say that Company X has created an assembly that is going to be like a sound engine. Okay, so it's going to have all sorts of classes internally that we can use for, well, working with sound. So here we are over here with our own game, and this will be a simple console app. So I'll put console. Though in the end, what is it? It is still an assembly. But inside our game, you know, we're doing all these things in our classes, but obviously at some point we're going to need to reference classes that exist over here in the sound engine. So this will be really cool. You guys will actually see Logan create a DLL here. and then show you how we can gain access to that DLL. So you're going to get a whole lot more out of this than just the whole basic, ooh, it's a class. It says internal or public. So Logan, let's go ahead and jump over to the other Visual Studio, and let's create our sound engine.
Okay. To do that, what I'll do is begin a new project, and for this project, I'm going to create a class library. And I'm going to name the class library right off the bat as, let's see, we've been using Sound Engine for the example.
Sounds good.
Sound Engine. And hit OK. This will create our project for our assembly, and it also drops in a class by default, which I'm going to erase out.
Okay.
So right now we're left at a new class library project with a namespace being set to Sound Engine and everything else clear.
I'd like to point something out. Notice how by default that class was set to public, where with a console app by default it's set to internal by not having a modifier exist at all. It makes sense. If you're creating a class library, well, the whole idea is it's going to be a library of classes in which another application could use. So odds are probably really good that they're going to be public classes.
Right, since the class library isn't technically a program in and of itself.
That's right.
You have to make those classes available to something that can use them as a program is running.
Exactly. Very cool. All right, so let's say we had like a sound channel and a mixer, just a couple of things that we could
Okay. Just make a few simple classes just to show that they do indeed work inside of this assembly.
Okay.
So first will be our class for our sound channel. And then we'll have another class called a mixer. Mixer. Alright, two simple classes. I'll build just for the sake of building and show that everything's indeed working.
Okay, now since Logan hasn't gone in there and actually put in a modifier, they are both internal classes. You want to go ahead and save this project as well so that we can go reference it over in the...
Or even this, if you want to take a look at where these rest right now, let's actually jump over to the class view for this assembly.
Okay.
And look at, there's our Sound Engine namespace. So inside of that we have Mixer and Sound Channel. If I pick on either of these and go to Browse Definition, we can look at the definition for the Sound Channel and see that it is marked as an internal class.
Very nice.
Even though we didn't specify, but as we were saying earlier, internal is the default, so anything without a specifier is going to be an internal class.
Exactly. Very cool.
And now, just to show that these are indeed working, for example, inside of Mixer, we could make a new sound channel if we wanted to, much as we have in the past in other projects. We could do something like the following, where we define a sound channel, just call it sound channel, and then we'll initialize it to a new sound channel, just to show that this is working. So from another class in this assembly, we can indeed use the class sound channel. In this case, I made a field and immediately initialized it.
Okay, very good.
Now, let's take a look at what we would need to do if we wanted to use this sound channel class inside of another assembly. So I'll jump back to our other assembly, which is the console application. Now, the first thing that we need to do is to reference the assembly itself, because that assembly hasn't been officially installed. Visual Studio doesn't know where to go about finding that, so the compiler can't find it to include it.
Okay.
So what we have to do first is make the project aware of that other assembly.
We need to go ahead and save it, or did you save it?
Let me see. Oh, I have not yet saved it. Yeah, that's one of the things. I'm going to save this because I set the project to Sound Engine. That'll create a Sound Engine folder for us.
Sounds good.
So yeah, good catch on that. Now back to the console application, where we can now go to the Solution Explorer under References, or under Project if you wish, and we can right-click on References to add a reference. This will take a second and look through all references. Now the way I want to add this is by using the Browse tab, because I'm looking for a specific file. I'm looking for the DLL file that the project created when it built. So I'm going to go into our Sound Engine folder, into Sound Engine, then into Bin, then into Release, where we should have a Sound Engine DLL file. I'll hit OK to include that, and now I have the Sound Engine assembly referenced within the console application. So now one might think that, well, if we want to go ahead and start using those classes, because that was the whole point of that assembly, we could do something like define a new sound manager.
You could actually just go ahead and set using Sound Engine up at the top.
Just to make this
just to make it a little easier for everybody. It'll feel more...
Right, and then the reason for this is the namespace we're trying to gain access to. So if we went into this assembly and said using Sound Engine and build, then everything builds just fine. So that just has it set up so that we could do an example similar to this. We don't have to do sound engine.sound channel. We can just say sound channel. So, well, I mean, you would think we could go ahead and try to use it.
Yeah, so let's say we needed to create a sound channel, which is going to handle playing and other things with our sound. Wait a minute, there's no sound channel.
So yeah, it hasn't lit up as the highlighting. And if I try to make a local variable for a sound channel and try to build, we immediately have a problem.
Now this is awesome. Look at the error that you get. SoundEngine.SoundChannel is inaccessible due to its protection level. Ooh, that's right, because it exists over in another assembly that has been marked internal. That class has been marked internal, and because of that, you cannot use the sound channel class outside of the assembly in which it was defined. So we can go back over to that other one and change that. So what Logan will need to do here is mark it as public. Okay, now with that, go ahead and close the object browser real quick.
Let's close this out.
Now go ahead and rebuild. Now let's go ahead and re-inspect our sound channel. So browse definition, and now you'll notice the public class sound channel. So it's public now. Very good. Now let's go ahead and jump back over to our other. Whoa! Check this out. Let's go. It's got color. Hit F6 real quick because they see the error and they're like, what's going on? Well, the error was just because Logan needed to simply hit F6 to rebuild. But now we only get a warning down there which just says that...
Which I could correct with this real quick.
There you go. Now he's going to make the warning even go away. That's just because we never actually used it after declaring it. There you go. Very cool. So now not only are we declaring the variable sound channel of type sound channel, we are also initializing it by creating an instantiation of the class sound channel and then pointing our reference at it. Okay? Very, very nice. So that right there demonstrates the need for internal and public. Do you want to keep it protected inside the assembly in which you're creating the class, or do you basically state that it's okay for other assemblies to use the class that you are creating? Is there anything you want to add to this, Logan?
Not really, just that usually it all comes down to how you want this class to be used. For example, if you had a program that had some code for a button, you have a button or the code for a find button. Mm-hmm. Obviously, that wouldn't generally be public because that's the find button for the specific application. When you do get into a case where you want to, I guess you could say, modularize your program and divide things up into different DLL files, then obviously you're going to want to use those DLL files as a library of functionality.
Right.
And in order to expose those classes, you have to make them public.
That's right. Real quick, jump back over to the sound engine and actually type in the word internal now so they can actually see it.
So we could replace public with internal, and that is indeed a valid keyword and still builds just fine. So again, as we saw in the object browser a second ago, which is probably still open from public.
Yeah, so all you got to do is just close it and reopen.
It's now internal. But again, internal in the same way that it was earlier when we specified no keyword.
That's right. Now watch this. Go ahead and go over to the console application without doing anything else. Look at that. All of our color highlighting that we had is gone. And if Logan hits F6 now, we've got a problem. We've got all sorts of problems because, well, due to, protection levels, we can't get to it. So that's very important to understand.
One other cool thing to show while we're doing object browser stuff is if I make this public again, and rebuild. Let me close this one out and verify from this side. So we again have a public version of the sound channel. If we jump into our console application, the assembly that's referencing Sound Engine, we can actually jump into the class view from our console app and look at available namespaces. If we look under project references, we can see we have the reference to the Sound Engine, which contains the Sound Engine namespace, and there's our class. So we can actually look at the class from the other side on the console application. There's our public class sound channel. This would be really useful if you didn't actually have the full source to the assembly you were using, but still wanted to take a look at it and see what was available inside of it.
Very true. And if you go back over there real quick and mark your mixer as public, you'll notice that it'll also show up inside that list.
Right, so I could jump over to the class, make mixer public, rebuild, jump to the console application.
It's already there. They're over on the right-hand side of your class view, or there. So very cool. I just wanted to make sure you guys have a very clear understanding about why you'd use public and what it provides for you, and why you'd use internal, which is the default, and what it provides for you. Basically just a way of protecting your classes so that they cannot be used by external assemblies. Okay, so with that, let's go ahead and jump back over to our whiteboard. So that takes care of our access modifiers. Again, this is access modifiers at the root level. The moment we start getting into nested classes, there are more modifiers that we can use, but all of these are going to become clear in the next videos when we start talking about members, because we're going to talk about fields and we're going to talk about methods and properties, and in going over each of those, they're all going to use the same access modifiers. There's several more when we get into private, protected, etc., and we'll go over those in detail, and at that point, what we described there will work for nested classes. Okay, so more on that coming up real soon. So with that, that takes care of our two modifiers we needed to talk about. Ching. Hey, it leaves us with one more thing. Wait a minute, you know what? Just for you guys. We talked about access modifiers. Let's talk about other modifiers. This is this is on the edge of in scope, out of scope, if you will, because we're not really ready to start talking about these things, but I figure if I throw them out there at you right now, you'll have at least seen them once and be kind of like planting a seed in the very far back of your head, so that when we get back around to really needing these particular modifiers, you'll be like, oh yeah, I remember that. So outside of the access modifiers, we have three more that I wanted to introduce you to. We have abstract, we have sealed, and we have static, which you've seen static. All right, so what does abstract means? Basically, it indicates that the class is to be used only as a base class. This means you cannot instantiate from that class. You cannot instantiate the class. You cannot create an object from it. No objects can be derived. Well, why would you want to do something like this, Logan? Why would you want to have a base class you couldn't create into an object?
Well, let's say in developing your program, you notice that out of all of the things that you had in your scene, you had assembled all of the common things, all of the common functionality and common fields throughout everything that you have in your program.
Okay.
And you've assembled them all into one class. But that class is so generic, it would never be useful by itself.
That's right.
It's like just saying something very close to object, like floor object. There's a lot of objects that could go on the floor, but nothing specific about any of them. And a generic floor object doesn't really mean anything. Or, as I say, as you're drawing out there, a game item. What specifically is a generic game item? It's almost more of an idea than a thing.
Right.
And in that sense, it is abstract. So in creating a class, you can make a class that is purely abstract, such that it can be derived from, it can be used as the parent of some other actual item. But in and of itself is not an actual in-game item.
That's right. And by creating it as an abstract class, you are securing the fact that it can only serve as a base class. It can only be extended. You cannot instantiate it. And as Logan was saying, in this particular case here, like game item, if we were to turn this into an object, what could this do meaningful for us? It's got a position X and Y and a velocity X and Y. That's just 3 pieces of data, or 4 pieces of data that it has. But what does it do? It doesn't really do anything, okay? But of course, the moment we come in here and we derive from this with some other object that has the rest of the functionality needed to give us, well, the benefit of a true game item that is perhaps of type player, well, then we can take advantage of all of this stuff that was provided by our base class, but it got inherited by another class down here. So now down here, of course, we have a position X, thank you very much, game item, and we have a position Y, thank you very much, game item, and velocity X, velocity Y, because of inheritance. It is, once again, abstract. It's just a way for us to go in there and say, hey, this class is only providing an abstract idea for an object, but it cannot be instantiated into an object, okay? So that is, so basically, where's my pen at? There we go. Only acts as a base. No objects. You guys write the rest of that. Okay, sealed. So a sealed class cannot be inherited, meaning that this guy right here cannot be a sealed class in this particular case, or I mean, because he can't be inherited, and we're demonstrating inheritance where we have, as I said a second ago, this guy was, let's say, player. Sealed class cannot, let me jot this down. Okay, so this guy cannot serve as a base class for other classes. All right, so the only thing we can do with this is just instantiate. All right, so if you end up in a situation where you've got a class that you will never derive from, you can create it as a sealed class. More on that a little bit later. Finally, that brings us down to a static class, which you have seen this a couple of times. With the static class, basically what's going to happen, when did I see this? I'm trying to think back to with our applications. We created it in Hyperion, didn't we?
Yeah, a few things were static in Hyperion. I believe the player and level were static.
Okay, yeah. So this is loaded automatically. At runtime. Now check this out. You might be thinking, huh? All classes that are going to get used get loaded, okay? This guy's going to act kind of like the object itself. An example, think about like the math. We've got a math object out there. Do we want to instantiate the math object every time we want to use cosine or sine? That would be a really odd practice. So the math class could be a static, which it is, a static math class, which just, once we're using it, it just exists on the heap. We can just use it. And remember, we talked about, let's see if I still have that picture up here, we talked about the nice thing about having static, when you have static members, it's just, you just have one of, period. So when we use a static class, what happens is the class would be loaded over here, and it'd look pretty much the same. You know, it would have its functions and all that good stuff. But with it, and it would also have all of its members, you could not derive, you could not instantiate that into another object. I was about to say you could not derive. Well, you can't do that either. It is just a class, self-contained, sitting there, end of story. Okay? And I think the math was a really good example. And the player was a great example of one, too, with our very simple layout of the game, the Hyperion project. We didn't want to have multiple players running around the scene, and in that case, we didn't want to instantiate a player.
Right, we didn't want to go through the extra work of having to be able to set up for handling, creating a player, basically having a blank, like call a blank variable, unfilled variable, that we're waiting to fill a player, and then have to have code that could handle the case of if we didn't yet have a player or we do have a player. That's where static can be convenient in those cases, is because, as with all classes, it gets automatically loaded, but we can use the class by itself. That means we don't have to worry about instantiating it ourselves and then keeping track of what we instantiated. We know that this is a static class. We just address it by its identifier, end of story. Right. We don't have to worry about making it or tracking it.
Precisely. All right, so with that allows us to check off modifiers because we've now looked at internal, public, abstract, sealed, and static. Okay? So that's the fourth key element to understanding basics of classes. That brings us down to the last one, which is creating objects. And we know that the basic syntax for that, if I move all the way down to the bottom, is as follows. Class identifier, variable name that we're going to hold the reference pointing at the actual instantiation of the class in, equals, then here it all is, the keyword new, and then once again class identifier. Open, close. Now there's a little bit more involved here when calling new, and the fact that you see that open and closing parentheses on the end, the call to the constructor and all that good stuff. Constructor may be a term that you've heard from time to time, or of course if you're coming from something like C++, you're very familiar with the term constructor. We're going to be discussing constructors when we get into Object-Oriented Programming 2, which is going to be coming up real soon here. So for now, just understand that this is what is required to instantiate a class. So this, once again, keyword new, this guy is going to generate a new object on our heap, and then we're going to get a reference pointing to it put over here inside our variable. And we've already walked through this in great detail back in the value types and reference types video. But you've seen this. Let me go ahead and just jump over here into Logan's console application and come back over here to the program. And right here, this was what? This was the class identifier. The variable name equals the keyword new, and then a call to the class identifier. You could say constructor if you wanted to with the opening and closing parentheses. But again, that's outside the scope. We'll be getting to that real soon. So again, class identifier, open, closing parentheses. Okay? And this is how we go about instantiating a class and then storing a reference pointing to that object in the variable that we define there. Okay? Anything you want to add to that, Logan?
No, I think that sums it up pretty well.
Okay, because with that allows us to come back in here, and let's go ahead and jump back to the top, guys, and check that off. That, ladies and gentlemen, are, as far as I'm concerned, the 5 key elements that you need to have a solid grasp on to really have a good fundamental understanding of classes. Okay? So as we said at the beginning, what is a class? A class is a blueprint or a template, but in more generic terms, it's a type. It's a type that we define. That blueprint is indeed used for instantiating the class so that we have an object that we can work with. And as we pointed out with the little drawing of the heap right there, let me come over here and just grab my pointer real quick. The heap, we will actually get the object type loaded into the heap. And this will become really important a little bit later when we start looking at static members. From there, we talked about the basic syntax. We saw that we had optional modifiers, then the keyword class, the identifier that you give it, and then the option to come in here and inherit. We'll talk about that a little bit more coming up soon. And then an open and a closing curly brace, and inside that we have the class body. What goes in the class body? Well, as we said, that would be members, the most common types of members, fields, methods, properties. But there are plenty of other types as well as constructors, constants, events, types, lots of things. From there, we talked about modifiers. We looked at the root level with classes, the internal and the public access modifiers, and Logan gave you a quick example of the ability to access a class defined in another assembly that's been marked as public, and he also showed you that by turning it to an internal, you couldn't access it. And then from there, after also jumping down here to the bottom, we did indeed talk about abstract, sealed, and static as 3 other modifier types that were available. And then from there, we wrapped it all up by showing you how to instantiate a class so that you can actually create an object. So with that is going to wrap up this video, which was an introduction to classes. Thanks a lot, guys.